Okay, welcome to Math 65, talking today about solving quadratic equations. We did start talking about this a little bit in 6.4. So in section 6.6 brings all of the factoring work together to solve equations and math applications by factoring and using the zero product property. Okay, remember we previously explored these concepts, so look back at your notes on worksheets and define the following. So what is a quadratic? Yes. Okay, so quadratic would be this. It has to be a second degree polynomial. Okay. What about the zero product property? What can you tell me about that? Yes, anything times zero. If A times B equals zero, anything times 0 is 0. So if A times B equals 0, then this means that A is equal to 0 or B is equal to 0. Okay? So this is the reason, these are, A and B are what we call what? If we multiply A and B together, what do we call them? Factors. They're factors. A and B are factors. That's the reason why we're actually factoring. So with our quadratic, we always have to set it equal to what number? In order to solve, we always have to set it equal to 0. We have to set it equal to 0, okay? So if we look at the first one, is it ready to factor? We're going to solve by factoring. What do we need to do? Yes, we need to add 30 to both sides. So we get x squared minus 11x plus 30 equals 0. First step is always going to be set equal to 0, number 1. Okay, then second step, what are we going to do next? Factor. Yes. So what numbers multiply together to give you 30? 5 and 6. Tell me about the signs. Aren't both negative? Both are negative. So what we're trying to do is we're getting to this place of factoring. We have it set equal to 0. That means if this is 0, the whole thing is 0. If this is 0, the whole thing is 0. What number minus 6 gives you 0? Positive 6. What number minus 5 gives you 0? Positive 5. So those are your solutions, you guys. That's it. Now, I don't have a lot of room to check on here, so that's the reason why you might get out some scrap paper for your check. And your check would look like this. If you take 6 and you plug it in, you have 6 squared minus 11 times 6 should give you negative 30. That would be your check. So you'd have 36 minus 66 equals negative 30. Negative 30 equals negative 30. You would want to check both of them. What about 5? 5 squared minus 11 times 5, is it equal to negative 30? 25 minus 55 equals negative 30, and that works as well. So you can always go back and check and make sure. Okay, let's do the next one. And what I would suggest is at this point, stop the video, try as many problems as you can on your own, but we'll just keep going through some of them. So can you tell me what I should do here? It's already set equal to 0, so what should I do? Now, is that true? Is this x plus 3, x minus 3? Look at that x there. Oh, what are you looking for first? Number 1 rule of factoring, look for A, G, C, F. There you go. It's x, right? So if you factor out an x, you get x minus 9 equals 0. That means that x has to be equal to 0. And what would x have to be equal to in order to give you 0 inside? 9. 9 minus 9 is 0. 0 times anything is 0. So if you plug that in, check and see if it works. Check 0 squared minus 9 times 0 equals 0. Yes, 0 equals 0. Now check 9. 9 squared minus 9 times 9 equals 0. That's 81 minus 81. So those are our checks. 81 minus 81 is 0, right? What about this one right here? What's the greatest common factor here? 6 and x. And what do you get? X plus 7. So that's a GCF, isn't it? Okay, we're literally going to, the way we solve this, we set each one equal to 0 and solve. X, 6 times a number gives me 0. What does that number have to be? Yep, x has to be equal to 0 here. What number plus 7 gives you 0? X plus 7 equals 0, minus 7, x equals negative 7. So you can also, of course, check here. We're just kind of rapid fire going through these, how we solve. What do you think you're going to need to do for D? That's got a lot going on. What do you think you're going to need to do first for D? Well, here it's not set equal to 0. Yeah, if you are going to subtract 30, can you subtract 30 from the form it's written in now? You would need to, yes, distribute. We need to distribute 6x squared minus 3x. Now we can subtract 30 from both sides, right? Okay, now I want to factor. But I noticed that everything here is divisible by 3, isn't it? So here's a little trick I can use. Since I'm solving, instead of factoring out, because I'm not factoring out an x, is that a legal move? If I do something to both sides, if I do the same thing to both sides, can I do that? I can definitely do that. 2x squared minus x minus 10 equals 0. Do you think that's a little bit easier to factor? Because everything was divisible by 3. So now if we factor, we need to use the what? AC method. Negative 20 and the sum is negative 1. Can you tell me those two numbers? Negative 5, positive 4. I was just like one step ahead of you, that's all. Just one step. But you see what I did is I split the middle, right? And why did I partner up the 4x next to the 2x squared? And why did I... Oh, yes, so that's 2x is the greatest common factor, and we get x plus 2. What's the greatest common factor of the last two? And we get x plus 2 as well. Now I'm running out of space, so I'm going to just grab a handy sheet of paper here so I can keep going. Okay, can you tell me the factors? Okay, so now it's not as obvious, this one. This one is obvious. X would have to be what? Here, I can always do this. I can set it equal to 0 and solve. I'm setting this equal to 0 to solve for x. What would I do to solve for x now? Add 5, 2x equals 5, divide by 2, divide by 2, x equals 5 halves. So your solution is negative 2 and 5 halves. Oops, 5 halves. So that's just set notation showing that I have, these are both x values. These are not ordered pairs. If you were going to graph it, the ordered pairs, the y-intercepts, oh no, sorry, not the y-intercepts, the x-intercepts would be 5 halves, 0, and negative 2, 0, right? Those would be the x-intercepts on the graph. That's what we were talking about before when we were graphing it. Yes, yes. Yes. Yes, the 3. It's not, because essentially if you were to instead of dividing it all by 3, let's say you just factored out the 3, okay? If you had the 3 outside like this as a factor, notice that 3 does not equal 0. Like that doesn't give me any kind of solution. So that's why it doesn't really affect the solution. When I have a GCF that's a number, not a variable, but a number, I can just divide it out because that's just the division rule of equality, right? As long as I do the same thing to both sides, I can multiply or divide the same sides or both sides by the same thing. Now, what would you want to do to set this one up to solve? We're on E now. Oh, you're asking about this 3? So what I was saying is if you left 3 in as a factor and you set it equal to 0, it doesn't give you any kind of solution, right? 3 does not equal 0, and there's no variable to solve for. So it doesn't affect your solution at all. It would be there if you were just factoring. Yes, you would want to leave there if you were factoring. But because we're solving and we can do whatever we want so long as we do the same thing to both sides, when you solve, you can divide it out. It's not going to affect your solution, is what I'm saying. If you're factoring, yes, you would need it in there. Okay, so what would I do here? I'm actually going to, for this one, I'm going to subtract 7x and add 2 to both sides because I don't want to make my x squared term negative. Otherwise, I have to factor out the negative. What am I going to do to solve this one? I need to factor, right? So what method should I use? AC method. AC, that's going to be 12, that has a sum of negative 7. Can you think of the factors? Negative 4 and negative 3, right? So now 6x squared, I don't care what, it doesn't matter which order you put those in. Do you have a preference? 3 with the 6, okay, and the 4 with the 2. I like that. You did that because you're thinking about like, oh, what do my friends have in common here? I want to, okay, so now I'm going to group, what's the greatest common factor of the first two? 3x, and we get x minus 1, right? What's the greatest common factor of the last two? I would say just negative 2 because they don't both share an x, right? There's no x on the last term. And since it starts with a negative, let's bring out the negative so that we get x minus 1 equals 0. Now we have x minus 1, and here we have 3x minus 2. I'm sorry? The 2 is here. Okay, equals 0. And again, I ran out of space. So here I have x minus 1 equals 0. So what's x going to be? 1. 3x minus 2 equals 0. What's x going to be here? Add 2. 3x equals 2. Divide by 3. Divide by 3. X equals 2/3. So my solution is 2/3 and 1. And again, if you take those numbers and you plug them in, you should check. And not check by FOIL, but actually plugging one of them in at a time to see if it works, right? Oh, you're right. I made a mistake. That's because I made a mistake. Okay, see how when we factor that out, 2x minus 1. Oh, good eye, good eye. Okay, so my solution is wrong. 2x minus 1, 2, x equals 1/2. Okay, both fractions. So that's why I missed it because I missed it because I made a mistake. So you found my mistake. Okay, does everybody see why I got it wrong? I divided out by 3. I should have had a 2. Okay. What about this one? How do we solve here? But this one doesn't have an x, so this one is sum and difference of two squares. Or no, sorry, this is difference of two squares. What am I talking about? So what's the solution? X equals 3 and here -3. Good. Okay, and this is partly, you know, this 2 in front here is another good reason why we should do our checks. You can even check on the calculator too. If you go back to your regular calculator mode, oops, second quit, and you just plug in 6 times, one of the solutions was 2/3. 2 divided by, oops, 2 divided by 3, parentheses, clear, oops. Well, anyway, I'm just saying if you plug it in, it will work, especially with the fractions if you know, because I messed up on that. All right, 2 more and then we'll stop this video and go to the graphing ones. Okay, so what should we do here? What is the first thing you're looking for when it comes to factoring? Yes. What is the greatest common factor here? 6x comes out, and we would get x plus 1, right? I'm glad I have such good eyes on me, so I don't make a mistake. 6x equals 0, so what would x have to be? 0. Here, x would equal -1, right, for this one. But for this one, x would equal 0. So our two solutions are 0 and -1. Oh my gosh, now this one has a lot going on. If it were set equal to 0, it would already be factored. But the problem is it's equal to 14. What do you think I'm going to need to do? You actually would have to FOIL. Because in order to subtract 14, right now, if I subtract 14 from both sides, I can't actually subtract 14 because I need to multiply all of this first, right? So we would need to FOIL, so we would get 3x squared. Now keep your eyes on me, make sure I don't mess up. 6x. Oh, plus 5x, I get it. 5x, okay. Last is -10, and I'm going to subtract the 14 to set it equal to 0. Can you handle that? Okay, so we have 3x squared. What's the middle term? Uh-huh. Because we had -10 minus 14. I guess I'm not the only one who makes mistakes, right? That's good to know. Okay, so now, of course, I'm running out of room. There's a lot going on in this problem, so let's get some extra paper out. We need to factor this, you guys. So, oh no, we got to do what method? Is AC method -72, is that right? -72 that has a sum of -1. Oh, I know it. I know it. Do you know it? 9 and 8. 9 and 8 give you 72 and have a, if they have different signs. Which one will have to be negative? The 9. Why is the 9 going to be negative? Has to be a -1. Okay, so for factor by grouping, 3x squared minus 9x plus 8x minus 24 equals 0. Why did I decide that I wanted to group? Why did I put the 9x first? Oh, you're coupling them up just so nicely. 3x, let's see if I do this right, x minus 3. Yeah, what's the greatest common factor here? +8. Uh-huh. X minus 3 times 3x plus 8 equals 0. Phew, it's hot in here. Is that it? Are we done? Oh, what do we need to do now? So we're setting them each equal to 0. Add 3. X equals 3. What about here? -8 divided by 3. X equals -8 thirds. Okay, so those are our two solutions. Again, I would suggest going back to the original problem. Both solutions, you can check them, you can plug them in. Okay. Does anybody want to see that, what that check would look like with the fraction? Okay, let's do the check. Let's just do the check, only the fraction one, negative fraction. I'm going to plug it into the original. 3 times negative 8/3 plus 5 times negative 8/3 minus 6/3. Why did I change 2? The original problem had a 2 in it. Why did I change 2 to negative 6/3 here? I have to have a common denominator, right? And you can do this in your calculator as well. So that cross cancels. Here we get negative 8 plus 5. Here we get negative 14/3. Negative 8 plus 5 is 3, negative 3, times negative 14/3. Does that equal 14? Yes. Oops, I wasn't even on the page. Sorry. So that simplified to negative 3. This simplified negative 14/3. Cross cancel, and you get 14 equals 14. So it worked out. Okay, you can also plug in the positive 3, and it should also give you the same result. Okay, this is way too long, so we're going to stop before we